There really is a logic behind time travel and impossible things like jetpacks and flying cars, starships. We physicists take it seriously. We have working designs in the literature for potential time machines. Of course, none of us have ever gone into one to find out whether they work or not.
Right. Well, one of the most famous time travel movies of all time is Back to the Future.
Absolutely.
Now, of course, it was a trilogy, but let's focus on the first one for the moment.
Which started it all and actually is the most beloved.
It's the most beloved, for sure. And it was 1985. I remember when it came out. And it was so well thought out, so well acted and performed and conceived. And let's just refresh our memory. Let's check out a clip from Back to the Future.
88 miles per hour!
Where the hell are they?
The appropriate question is, when the hell are they?
Yeah, it's not where are you, when are you?
Yeah.
And so, in fact, Einstein does come back. That was not the dog driving the car, although it looked
It
like
did kind of look that way.
It did kind of look that way.
And I think Michael J. Fox was a little too muted on his response to seeing his dog disintegrate.
Or to see a car come at you at 88 miles an hour.
At 88 miles an hour, and you stood there.
And you stood there.
A lot of trust in the doctor.
That's right. So, well, it's Doc Brown that I met up with for my interview for Star Talk. And he's a deep thinker, and we just talked about that iconic role that he gave us in that film. Let's check it out. No one can imagine anybody else playing that role but you. So what were you doing? What's your secret? Come on.
I love the whole concept of scientists who deal with insoluble problems. I love the story of a noted scientist who was trying to find the solution to some problem and just didn't come. And he worked on it for months. And then one day he's not thinking about anything. He's getting on the bus and it comes to him, you know. And Doc Brown is trying to figure out how to do time travel. And he falls down in the bathroom and hits his head against the sink. And he suddenly envisions the flux capacitor. You know, so I love that kind of connection because it's kind of the way it works.
Well, so it's interesting. That's basically the eureka effect.
Yeah.
You get hit in the head or something happens to you abruptly, and then the idea pops in. But I'm a fan of the way Isaac Asimov interprets the eureka effect.
Which is? Go ahead.
Okay, you ready? The most exciting phrase to hear in science, the one that heralds the most discoveries, is not eureka, but rather, that's funny.
That makes sense.
Yeah. So, Michio, do you agree with this?
Yes, I had exactly that moment. I first was working on string theory in the 1960s, and it consisted of hundreds of random formulas that you had to memorize in a book. But Einstein wanted an equation 1 inch long that would allow him to, quote, read the mind of God. So I said to myself, that's funny. How come this theory has so many random equations? There should be this 1 inch equation. One day, I found it. It's called string field theory. That's my equation. I'm the co-founder of string field theory, and it summarizes a theory beyond Einstein in 1 inch long.
Wait, but was that a eureka moment, or did you just sort of...
It was that funny moment that no one was looking for it. No one was looking for this 1 inch equation, right? Because people were so busy memorizing and using all these hundreds of little formulas that they would memorize. No one was looking for that 1 inch equation.
So my famous That's Funny story is with William Herschel, who wanted to measure the temperature of the different colors of light that come through a prism.
Okay.
Just to even think to do that
Yeah, listen, that's all I can say is a mushroom tea night for me.
Wait, so he's got the spectrum laid out. And he puts a thermometer in each color. And then he says, all right, I need a control thermometer. So he puts that thermometer beyond the red side of the spectrum where there's no light. And then he watched the temperatures. And the one where there was no light, just beyond the red, rose to the highest. And he said, that's funny. There's no light there.
Right.
The man discovered infrared. which is not visible.
So there was light there.
There was light there.
You just couldn't see
He
it.
thought he put it in a safe place.
Right.
That was a that's funny moment. And then Isaac Newton, which I think is more of a eureka moment. The man is sitting outside his backyard in Lincolnshire, all right? We filmed part of Cosmos there.
Right.
It was almost like a pilgrimage going up. I was feeling that Isaac.
Well, I know that's your favorite. That's your favorite guy, right?
That's my boy.
your man.
That's
right
my
there.
man.
That's your man.
I go
right
visit
there.
my man.
Right.
And his apple tree is still in the backyard. Okay. So after I got a hold of myself, I bit an apple next to his tree, and then I floated up off.
So the apple story is true.
Well, yeah, but what happened was he saw an apple fall. He didn't get hit in the head with it. He saw it. I know. He saw the apple fall.
I'm gonna erase that. Wait. Erase. Go ahead.
And he saw the moon in the sky, knowing that it orbits the Earth. And so here's an apple falling straight to the Earth, and some other orb going around the Earth.
Right.
And in that moment, he recognized that the same force is making both things happen. So it takes Newton to have an apple falling in a straight line and a cosmic object going in orbit to drop it into one equation. He's in your one equation club.
That's
is that right?
Okay.
Michio.
No, that's the first unified field theory, because they unified Earth-like physics with heavenly physics when the church says they were two separate things. One heavenly physics that God would obey, and then the venal and mortal sin that we lived in. He created the first unification in all of science.
Interesting you said that God obeys the law of physics. That's an interesting inversion of how most people think of God.
Yes, because most people think that God actually created the laws of physics.
Yeah, but Michio has separate access to deities. I've learned this. Let's go back to my interview with Christopher Lloyd. It turns out, though he plays a geeky scientist, he's actually got some geek in him, in real life.
Oh, yeah?
I love finding that out in people. Let's check it out.
Einstein always kind of amazes me. And there was...
He amazes us all, by the way.
Yeah,
yes.
yeah. And he was just a clerk in the patent department.
Yeah.
Nobody knew, but he's kind of looking at this, and there's a railroad station, and he spent a lot of time doing mind games. What are they called?
Thought experiments. Yeah, your Gedanke experiments.
Having to do with if a train is moving through, and somebody drops a ball and it bounces, how fast and how it relates to the world outside.
These
somebody
are
on the platform.
Seeds of the genesis of relativity.
And there was a famous clock tower over the railroad station. So there was time, travel, all that kind of stuff going on.
So he loved himself some Einstein. And so in 1905, he had special theory of relativity, which involved the trains and the clocks and the timings. And then 10 years later, 11 years later, the general theory of relativity, which had yet another affirmation of its reality in the discovery of gravity waves.
Yes.
But just recently. Could you describe in 30 seconds or less?
No, listen. No, wait. Michio, I've done this with him, so now I got to do it with you. Okay? Can you, in less than 20 seconds...
20 seconds?
Less than 20 seconds, can you explain gravity waves, okay? But first, you got to let me get my clock. All right, now I have my clock. Okay, wait, I have my stopwatch, and you have 20 seconds, and go. Gravity waves.
If space-time is like the surface of a pond and you throw a rock in the pond, ripples radiate just like gravity waves. Gravity waves are like ripples on the space-time of a pond.
That was 13 seconds. You got 6 more, man. 6 more seconds, man. What are you doing to me? God. No, that was awesome.
Okay. Okay, wait. Let me take his remaining 6 seconds and add to it. You ready?
No, I'm going to give you another 20 seconds. Hold on.
Okay.
Hold on. Ready?
No, I just need the extra 6 seconds.
You just want 6 seconds.
He ceded the 6 seconds to me.
Now, why you gotta
the senator from whatever. Okay, you ready?
All right, ready? Hold on and go.
The difference is the surface of a pond is in 2 dimensions, but gravity waves occupying the 4-dimensional continuum of space-time radiate in every direction.
9 seconds.
Oh,
You lost.
Beep,
Is
beep.
that okay? Is that a fair supplement?
Yes. Now, also, if you spin that pond and get a whirlpool, that is the beginning of the first time machine that was written down in 1949. The first time machine would be a whirlpool on the surface of that pond.
Right, which is not really a pond at all, if I'm following you.
There's no fish in this pond.
It's actually the fabric of space itself, right? And
In 4 dimensions.
He's got it.
Okay.
He's got it.
All right.
In 4 dimensions.
In 4 dimensions.
All 3 space dimensions and a time
And a
dimension.
time dimension.
Right.
So it's X, Y, Z, and some other stuff.
Called T.
T is an actual, well, it's not an axis, but it's
Yes, it
there's
is an
a
axis.
T-axis.
T stands for
Time.
time.
Right. So
How could you get that close to it and not do X, Y, Z and something that represents time?
Because
T. We got this.
I like to keep it on the low, man.
So Michio, did you pop a bottle of champagne when the gravity waves were discovered? You just knew they were going to come anyway.
It was predicted 100 years ago. We knew that we were going to find. In fact, if we didn't find those gravity waves, we would have been in deep doo-doo if that had happened.
You could say he would be in deep. Okay? Translation from the theoretical physicist. He would have been in deep.
By the way, that was the end note of Einstein's actual theory. If this doesn't work, I'm in deep.
It's in his notes. I read that. It's in German, but it's in his notes. So, Michio, relativity is a modern idea of how the world works, and it doesn't seem to emanate from anyone's sort of chair, because it's not part of anybody's common sense.
That's right. Common sense says that time is like an arrow. You fire it, never comes back. 1 second on the earth is like 1 second on the moon. Einstein says, no, time is like a river that meanders and speeds up and slows down. And the new wrinkle on this that I work on is the fact that the river of time can have whirlpools and fork into 2 rivers. And that, of course, is Back to the Future. Whirlpools in the river of time.
Man, that sounds like a really cool soap opera that I... And now on the next episode of Whirlpools in the River of Time.
Well, so in your book, The Physics of the Impossible, you actually classify impossible things, and you classify time travel as a class 2 impossibility. What the hell does that mean?
Class 1 impossibility are things that are actually possible, but most people think they're not. Like, for example, jetpacks, starships, teleportation. They're all physically possible. In the laboratory, we actually teleport atoms.
So there's no law of physics preventing them.
That's right. But people think they're impossible because you see them on Star Trek.
They've only ever seen them in a science fiction story.
That's right.
Okay.
But we have jetpacks. We have, we can make flying cars. We can do all that stuff. Except we go to class 2 now, where we really have problems. Now we're at the cutting edge of physics where I do my research. That includes wormholes, higher dimensional travel. This includes black holes and what happens at the center of a black hole, wormholes, time travel. These are class 2 impossibilities.
I'm afraid to learn what class 3 is after hearing that.
Class 3 is just darn impossible, period.
Just plain old impossible.
Like violation of the conservation of matter and energy, getting something from nothing.
Right.
Okay, that would be a class 3 impossibility.
Or my wife letting me go to a strip club.
So that's class 4.
Impossibility.
That's class 4. Okay.
Class 4.
Not in your lifetime.
Well, there have been people who tried to make time machines in the past. And most famously, we have H.G. Wells in 1895 with a story called
The Time Machine.
The Time Machine.
That's
very
correct.
good.
Yes,
that was very sort of a steampunk. It had like pulleys and levers and handles.
Yes.
And
that was very cool, though.
That's pre-Einstein.
That was pre-Einstein.
And he introduced the 4th dimension. He says flatly the 4th dimension in the opening paragraphs of that novel.
And you know what I loved about that is that he had to move the time machine in order to move the place that he went in time.
Yes. So H.G. Wells thought that through.
He thought that through.
Right,
It was a very...
By the way, this is something that most people don't think about. Because if I say, I want to put myself, I want to go back 2 hours. Okay? If I do that, then I'm in space because Earth has moved in its orbit.
Right.
So you can't just move in time. You got to move in space if you want to keep your butt in the chair that you started in.
Right.
So H.G. Wells, 1895, The Time Machine.
The Time Machine.
That one took people to new places, psychologically, intellectually, scientifically, and that wasn't the last time people have tried to do this. The most successful and longest running science fiction series, Doctor Who.
True.
It's got a rabid fan base in the UK.
Frightening people. Just gonna say.
And the fan base, we got a strong fan base here in the United States.
Yes.
Including my daughter, who's a Whovian.
Listen,
they got words. If you are, you're a Whovian. And,
yes.
and it started in 1963.
Yes.
So if you knew about those, you're classic Who. But then they rebooted the series in 05. If you're into that, then you're New Who.
New Who?
You're New
Who knew?
So that series involves time travel.
Yes.
Let's check out what they do. Evil?
That is a frightening woman.
So, Doctor Who follows the adventures of a humanoid alien called the Doctor. Okay? That was not the Doctor. That was the Doctor's nemesis. That nemesis is called the Master. And they occasionally will face off to one another. And all of their adventures involve moving through time in some way that is always intriguing. Always, they force you to think about the consequences of having done so and what they're doing in that time and place and what effect that'll have on everything else in the universe. And so that woman who zapped this other woman out of existence, the woman who plays that is called Michelle Gomez. And she is the first woman to play the role of a Time Lord.
Time Lord, yeah.
She's and so she came by my office. And I had to ask her about this. What are the powers that you have? Because we all know about the Doctor's powers. They're both Time Lords, but they're nemesises of one another. So let's check out the actual powers of the Master. Could you list for me the powers of the Master?
Being able to time travel.
Time travel, but with your vortex.
Yeah, at the moment with the vortex
with
manipulator.
your non-TARDIS vortex.
Very ugly. So there's that, I would say, is basically that's
the thing.
That's the thing. I mean, she has there's other gizmos and gimmicks and things that she has at her disposal to delete you.
So not just kill me, but delete me. That sounds worse than just killing me. Because if you just kill me, my dead body is here, and then you have to bury me or think about me.
But then you'll still be here somewhere in the cosmos.
Yes, my sense of self and memory of me is there. If you delete me...
Yeah, you never existed.
That's scary. Well, so here's what's interesting. The fact that she can delete you rather than just kill you means she has access to your prior existence.
Right.
Because you're deleted, it means no one even knew that you existed.
Yeah, that's some really angry girlfriend stuff right there.
Chuck, you sound like that's happened to you.
I'm just saying.
Which girlfriend was that?
I know.
All I'm going to say is there's a lot of places on Facebook I don't exist.
So the Doctor uses a TARDIS, which is a call box. Missy, which is her name, the Master, she uses a vortex manipulator to travel through time. That's basically her time machine. But the TARDIS, though, is that's an acronym. TARDIS.
I didn't know that.
Time and relative dimension in space. That's why you'll always see it capitalized.
Right.
And it looks for all the world like a
phone booth.
A phone booth. A police call. But you walk in and it's bigger on the inside.
Right.
That is an entire place on the inside. Michio, that clearly involves another dimension.
That's right. These are called multiply connected spaces. If you get a scissors and paper and Scotch tape and start to cut and then reform in different ways, you can get wormholes, you can get TARDISes, multiply connected spaces which wrap around themselves. We physicists have cataloged these things. And so if you have enough energy, perhaps you can warp time and space into a pretzel.
Pretzel, you think you're going someplace, and by the time you turn around, you're back where you started.
That's right. In other words, whirlpools in the river of time. And you can see this by taking a sheet of paper and folding it on itself, and then punching through it, and that's called a wormhole.
connecting this part of the space-time continuum to this part, cheating really by not having to go through the full length.
Now, to actually build something like this, you need a machine bigger than the super collider in Geneva, Switzerland, the Large Hadron Collider.
Oh, how much bigger?
A quadrillion times bigger than the Large Hadron Collider.
Yeah, so that's not just bigger, Michio.
It's a lot bigger than the Large Hadron, a lot bigger than the city of Geneva. But if you had that energy, then yeah, you too might be able to rip a hole in the fabric of space and time. In fact, we think that energy is perhaps the energy of the Big Bang.
Wow.
The Big Bang, the creation of the universe itself might have come out through a wormhole.
So let the record show that Michio wants to tear a new one in the universe. When we come back, more on the physics and fantasy of time travel on Star Talk. We're back on Star Talk. And tonight we're talking about time travel, the physics of it, the fantasy of it, the pop culture of it. Featuring my interview with Christopher Lloyd, who played Doc Brown on Back to the Future. Check it out.
My fiance had been trying to get me to a little more technology adept, so I carry all these books with me on a plane, and she says it drives her crazy. So she's trying to get me on the Kindle.
On the Kindle, yeah.
She said, now choose a book, and we're going to be taking some long trips. And all I could think of was Steve Hawkins' A Short History of Time.
Brief History of Time, yeah.
Brief History of Time. And she says, why did you choose something that's fun? And I said, this is fun. And it is. I don't ask me to explicate about black holes or anything, but I love reading it. It's just so awesome.
So Michio, A Brief History of Time, Stephen Hawking, that single-handedly put physics back on the map in pop culture, ever since Einstein was a pop culture icon. He proposed the chronology protection conjecture. Did I even say that right?
That's right. However, we think he's wrong on this one.
Well, wait. So first of all, so he's saying that backwards time travel is impossible, A. B, you're saying we think he's wrong. Does that mean you think he's wrong? When the word we comes out of Michio's mouth, who is the we?
I don't know, but I just think this is awesome. Like just sitting here and listening to astrophysicists talk about the fact that Stephen Hawking is wrong. Awesome.
He himself has stated that he is unable to prove that hypothesis, which would disprove time travel.
But that's why it's a conjecture.
It's a conjecture, but it's never been proven. And that's why he cannot say that time travel is impossible. He tried to codify the impossibility of time travel. He failed, meaning that it could be possible.
Damn, that was a Stephen Hawking smackdown.
But there's some other arguments here. There's sort of the practical argument. So, for example, if in the future a time machine is invented where you can go backwards in time, presumably they would have already done so. Where are they today?
Well, we're going to have invisibility in the next few decades, so maybe they're invisible.
See, you pulling stuff out of your... No, but Michio...
Maybe they're here. Maybe they're here, right here.
You're telling me you're right and Hawking's wrong because they've actually come back in time and they made themselves invisible.
That's right. We're going to have
Wouldn't you, though? If you went back in time, you wouldn't let people know that you were from the future, would you? I mean, seriously, you would not go back because, first of all,
wait.
They would take you and put you in a room.
No. First, no. Chuck, as you know, there aren't many times in the history of this civilization that either you or I ever want to go back to.
Well, listen, I'm going to tell you right now.
Okay?
No, Michael J. Fox went back to 1955. There's no way in hell I'm going anywhere near 1950 anything.
That's exactly right. That's what I'm saying.
As a matter of fact, I'm not going past 1980. Things get a little sketchy for me right after they invented hammer pants. So like if I go back and I don't see hammer pants, I'm like, nope, I'm going back now.
So they're invisible. All right, but there are other interesting things about backward time travel. For example, I remember the film, I don't know how popular it was, but Somewhere in Time. That was the film that had Christopher Reeve in it.
Right.
Reeves, and he falls in love with a woman. He's young and dashing, and there's an 80-year-old woman who he encounters and she says to him, "Come back to me." And he wants, what's going on? and she gives him a ring. And she finds out that she existed 70 years earlier in the century. He sees pictures of her, and then he figures out how to send himself back in time, and he goes back in time, and then he meets her. And he has to then introduce himself to her because she doesn't know who he is. And then they meet each other, and he gives her that ring that she had later given him in the future, which means the ring was never created. It only exists in this loop.
In the loop of time.
And so
it's a whirlpool in the river of time. Right. They needed Match.com to sort that one out, right?
Yeah, that one was... no, I was intrigued that you can have a thing that exists when you have backward time travel that was actually never created.
Now, it's even worse than that. If you have time travel, you can be your own mother and your own daughter, your own father and your own son.
Well, now I'm done with time travel.
Let's say I have a woman...
Wait. So what you're saying is these paradoxes are not really paradoxes if they're allowed by the laws of physics.
Yeah, we think that they could be allowed by the laws of physics because the river of time forks into two rivers.
And that's how you get babies, too.
And as a consequence, you've changed somebody else's past. That woman that you meet in the past who's a teenager that falls in love with you looks genetically similar to your mother as a teenager, but is not. The river of time has forked into two rivers, and you've jumped stream to another timeline.
Okay, so now get back to your situation here.
We physicists have actually taken that paradox apart, that you can, in fact, be your own mother and your own daughter.
Wow.
And grandfather and great-granddaughter.
That would even confuse Lady Gaga.
I'm...
Speechless.
So, in any of these scenarios, does the universe split?
That's right. We get what is called a multiverse of universes, where time travel is possible without any contradictions. And if you saw Back to the Future Part 2, when they go backwards in time and Biff steals that almanac,
yes.
Doc Brown goes to the blackboard, draws a horizontal line, and then he forks that line where Biff steals the almanac. That is a physically correct description of all time travel paradoxes.
Okay, let me correct you. No, it's not that it's correct. It's that it doesn't violate laws of physics. We don't know if it can ever happen that way.
That's right.
Okay. Just to say it's correct.
It's consistent.
Like you've confirmed this.
It's consistent with what we know about the laws of quantum mechanics and general relativity. It's consistent.
So therefore it cannot be excluded.
That's right. And that's why Hawking has since backtracked on his chronology protection hypothesis. We have not been able to prove that time travel is impossible.
So what?
No, I was just going to say once again, Stephen Hawking, wrong.
So what you're saying is if the time machine is invented in the future and all this is happening, we start splitting the universe every time there's something that would have been a paradox.
Right. You see, usually people would say that historians are going to be out of a living because history can be changed anytime, and the unemployment lines would have a lot of historians on them. Now, there's a historian on every timeline, you see, and they have a job. So history is still possible in each timeline.
Okay. So what you're saying is if I go back into my own timeline and do something different, a whole other universe births for me.
That's right. The multiverse.
For me.
That's right.
It didn't have to until I required it of the laws of physics.
That's right. A parallel universe emerges when you go backwards in time. And this is consistent with quantum mechanics, where we talk about multiverses all the time. That if our universe is a bubble, as Einstein said, and the bubble's expanding, there are other bubbles out there.
Well, coming up, the science fiction of time travel meets the science fact. And one of my interviews featured Michelle Gomez from the pop series Doctor Who, the BBC cult classic. Let's check it out. Answer me this. The Time Lords always tended to have companions traveling with them. So if people can travel with them, then they too are traveling through time.
Yes.
So the act of traveling through time is not unique to Time Lords. if you can bring people along with you.
Yes, and that does seem to be happening now. I mean, he's just sort of, anybody can just jump in the TARDIS with the
Just
Doctor.
jump in right before it takes off, and then you're there.
But no, that's the fun of it. You've got to there's something about the shared experience that we need as humans as well. There's something about turning to that one person in the dark and sharing that experience. So I think that's where the Doctor and the Master are entirely different. The Doctor shares that with somebody and then gets to tell the story, and the story then gets to
propagate.
To propagate.
Whereas
with the Master,
no companion.
There's no companion.
So you travel through time alone.
Yeah.
Space-time alone.
Yeah.
So, Michio, when you invent your time machine, are you taking friends with you?
No, I don't think so. I think it's a personal journey, and I don't want to be deleted if they make a mistake.
So, Time Lords on the show, they're all from, I guess it's the planet Gallifrey, and they form a community of people, and they're capable of manipulating space and time. It's just a feature of their identity, and it's their most defining property of who and what they are and what they do. And what this show has done is it's split that identity into good and evil.
Right.
Yeah, so you have the Doctor and you have the Master.
Right.
So Michio, here's an interesting question that I've got. Physics and our understanding of the universe has advanced greatly, as it always does, every year, every decade. And so it's almost come to the point where we are now taking time travel a little more seriously than ever before. We're at a time when people like you are actually thinking this.
Yeah, several things have happened. First of all, we've discovered numerous black holes in the universe. There's one in our backyard. The Milky Way galaxy weighs 2 to 3 million times the mass of our sun.
Right in the center of the Milky Way.
That's right. These black holes collide, giving us ripples in the fabric of space and time.
Backyard in this context means 35,000 light years away. Okay? That's backyard cosmically. Go.
Right, and these black holes rip the fabric of space and time. And according to the theory, if a black hole's rotating very rapidly, it doesn't collapse to a dot, it collapses to a ring of neutrons circulating very rapidly.
So a ring, you mean like a donut?
Yeah, and if you fall through the ring, you're not crushed to death, you wind up in another universe. So there is a wormhole, mathematically speaking, at the center of every black hole that is rotating very rapidly. And if you go through the wormhole a second time, you wind up on a second layer of a parallel universe. Now, why don't we...
So it's universes all the way down, is what you're saying.
That's right. The parallel universe is all the way down. Maybe even Elvis Presley is alive in one of those universes, right? So
thank you very much. So is there a universe where this Elvis Presley say, I'm not thankful? That's evil Elvis, right?
I'm not thankful at all.
You even had the lip doing it.
Yeah, that's right.
But can we stop interrupting Michio here?
Michio.
Okay, go.
The other reason for taking this very seriously is we have the Large Hadron Collider now, this gigantic atom smasher, 14 trillion electron volts worth of energy. We can create a mini black hole, a mini Big Bang at the center of the Large Hadron Collider. And so we have to take them seriously now. At what point does known physics break down?
Well, up next, we're going to come to one of my favorite segments of Star Talk, the Cosmic Queries, where we field all the questions you have on time travel. You and I do this all the time.
All the time.
And these are questions solicited from our fan base. I won't necessarily know all these answers, but I got Michio as backup.
Yes, you do.
I got my bell. Okay, let's check the bell. We got it.
Bell works.
Go for it. Yes.
All right. Query number 1 is from @theatrical. Is time just the universe's way of organizing space so that it doesn't run into itself?
Ooh, Michio, why don't you hit that?
Yeah, time is a parameter that measures change. That's what time is, a parameter that measures change. And because it measures change, it means that things don't collide. It separates things.
So yes is the answer. Okay.
All right. Query number 2 is from @KDR Guitars. What would happen if your atoms if you travel back in time? Surely the atoms within you already exist elsewhere in the past too.
Ooh. Whoa. Yeah, Michio, why don't you take that one too? Yeah. I could answer these, but I just want to give Michio a chance.
Well, The river of time means you go backwards and meet yourself in the past, and so your atoms exist simultaneously because you're on another timeline. So there are no paradoxes.
No paradoxes.
So when you meet yourself as a child, that is not really you. It is genetically equivalent to you, but it is you in a different timeline. So your atoms exist simultaneously.
So the act of going back in time split the space-time continuum, so you were meeting you, but they're not your atoms.
By God, he's got it. He's got it.
Good. Next one.
Sweet. I'm going to go back and meet me and slap the hell out of that guy. Our next query from Raymond Pinzon in Lake Forest, California. Let's say you can ride a photon. How would your surroundings look like while you are on it? Would you be able to perceive movement and time?
Let me take half of it, and I'll give the other half to Michio.
Okay.
Photons have no concept of time. Time does not exist for photons. If you are emitted any place in the universe, you are absorbed at your destination that very same instant. Yet to the rest of us, you'll see the photon move at the speed of light across the thousands, and in some cases, millions and billions of light years to its destination. So when I'm at a telescope and I'm observing the center of the galaxy, as I did for my PhD thesis, those photons wandering through space ended up in my detector. They hit that in their mind the instant they were emitted from the stars at the center of the galaxy. What would the universe look like if you are surfing that photon?
You're right. The universe would be stopped because time as we know it, as a parameter of change, does not exist on the light beam. So you're correct.
But what would the universe look like to you? Oh, it just stopped.
It just stops.
Yeah, okay.
So it'd be frozen.
Frozen, right.
Wow. That's very cool.
Yeah.
Hit the bell. And from at NG1083, is it true we may be able to see into the future, but will never be actually able to time travel?
Well, already our astronauts are time travelers. Our astronauts, when they come back, are like a microsecond younger than a twin if they had one on the planet Earth.
I tweeted how much younger Scott Kelly is than any twin that he left here on Earth after he had been in space for 10 months. You just run the straight Einsteinian calculations. You learn that in Relativity 101.
Right. And if you travel to Jupiter, since time is distorted around Jupiter, time slows down. It means you go forwards in time going around Jupiter. So you can become a time traveler into the future. It's going into the past that's the big problem. But forward time travel takes place with all our astronauts.
Yeah.
All right. Well, there you have it. Hit the bell.
Well, coming up, we've got Bill Nye the Science Guy. And guess what he got his hands on? The actual DeLorean from Back to the Future.
Oh, man.
And I don't know what he's going to do in it, and he didn't invite me on that trip. But when we come back, we will find out what he does with that DeLorean on Star Talk. We're back on Star Talk, and we're talking about the science and pop culture of time travel. And who better to ask about that than Doctor Who star Michelle Gomez? Check it out. Does the prospect of time travel intrigue you?
Yes, absolutely.
How long? Of your whole life?
From the moment I think my first thought would have been obsessed about
Really?
being somewhere else. And it's only until now that I'm starting to realise that right here, right now, in this moment, right in this moment, everything's just fine and perfect. But that's taken me a few years to get there.
So your timeline was a work in progress until this moment.
Yes, because it had to be beaten into submission. My very sort of humanness has had to be beaten into me throughout the years.
Well, it's true for anyone. We are the sum of everything we've experienced.
Yes.
Right? But not everyone puts it together into a new entity.
Consciousness.
A new consciousness.
Yeah.
A new consciousness.
Wow, man, you guys got really philosophical.
Well, I'm just saying, if you got to go there, you got to go there. Sometimes the moment requires it of you.
Yeah.
So, Michio, what is this? If there's time travel, what does that say about free will?
It means perhaps there's no such thing as free will. We have to.
No one wants to believe that.
Right. However,
I do. My life is a wreck.
I'm a quantum physicist, and in quantum mechanics, there is uncertainty. And uncertainty means that we're not robots. We're not...
By the way, this is not uncertainty the way we normally use that word.
This is the uncertainty in position and velocity of electrons. But since we are made of electrons, it means that there's uncertainty with regards to who we are. We exist in multiple states at the same time. And in some sense, you can be two places at the same time. So for us quantum physicists, having multiple universes is commonplace.
If you're going to give yourself multiple universes, then I do have free will. There's a universe where some happen. I say, I don't want to do that. I don't want that to happen. Right. Let me go change that. And then I birth another universe where I can do something different.
That's right. If there is uncertainty, then there are parallel universes, different time streams, and that resolves all the paradoxes of time travel. And it means that free will can exist because the timeline can fork into many roads.
So each one of those timelines actually represents a different reaction to a choice. If you were this person, so I get up and I went one way to work as opposed to another way to work, I've created a different multiverse by doing that?
We create multiple universes simply by making decisions. Right. Whether we wake up in the morning or sleep another hour in bed, we bifurcate, we split in half. And so for us, the time travel paradoxes are very easy to resolve because we work with parallel universes every time we work with a transistor. The internet is based on parallel universes. And some people don't like it, but hey, get used to it.
Still, Michio, I think you're invoking parallel universes to make everything you say work out okay.
Hey, I think he's got it. That's exactly right. We believe in a unification of all physical law. And we think that quantum mechanics is the framework that even unites Einstein's theory to quantum mechanics. And the highest version of quantum mechanics is string theory.
So I worry that you know you can make another universe rather than commit yourself to this one and make it better.
Oh, can I dodge that question?
All right, so before we bring this to a close, you know we can't do it without, like, a video visit from Nye Times in the City.
Yes.
Bill Nye, the science guy, good friend and buddy. And now, you know, he's a resident of New York now. I finally got him to live here.
You finally got him here.
Now he runs around town doing cool stuff, and I'm still here stuck in this chair. So I'm told he got his hands on an actual DeLorean that was used in the movie. Let's check this out.
Look out!
Is time travel possible? No, probably not. Be cool, though. You could go back in time and change history. Maybe you could go back to the Titanic and convince the captain to slow down. Or maybe just go back to last weekend and stop yourself from having one more tequila shot. Or maybe you could send a colleague back in time to have sex with a waitress who turns out to be your own mother, like in the Terminator series, you know, to prevent worldwide nuclear war. That'd be cool. Science fiction is replete with time travel stories. But I think for Neil and me, our favorite's got to be the Back to the Future series. That's where Doc Brown turns a DeLorean sports car into a time machine. What if you could travel through time? Great Scott! Suppose everyone you know and love, were actually part of someone else's time travel adventure. That would mean that you and I don't even exist. And as I finish this Nye in the City segment, everything would just disappear. That would be weird.
Where did he go? So let's try to land this plane. So Chuck, what are your reflections on time travel?
I think it's great to think about, and it's a lot of fun. But would I actually want to go back in time, to be honest, and change something? No, that scares the hell out of me, to be honest.
Michio, what wisdom do you have to drop on us?
For physicists, time travel is like children's paradise, being in a toy store as a child. All the toys to play with, all the laws of physics that we might be able to break or extend. So we're talking about a whole new terrain opening up. So this is a great time to be a physicist, because we're like children in a toy store.
So your time machine tools and methods are in like a playpen for you.
That's right. We get to test the boundaries of theoretical physics. We get to play God. We get to change the laws of physics because the old ones don't quite work right.
Well, clearly nothing wrong could ever go from that.
What could go wrong there?
What could go wrong?
Maybe time machines have been invented in the future, and they are sending people back. But they're not sending them back invisible. They're sending them back as those who walk among us and end up transforming our world, whose ideas are well ahead of that of anything else that's going on around them, such as Isaac Newton himself, Einstein, Jimi Hendrix, Marie Curie. Maybe these people who we write stories about, these people who were ahead of their time, Picasso, people where they did something and no one understood it. We had to keep moving the timeline forward until somebody said, hey, they were onto something. Maybe they are the time travelers in our culture and we don't even know it. And so if you see someone making discoveries, give them a hug. They're trying to help us save us from ourselves. That's how I think about it. Just a thought from the Hall of the Universe on Star Talk. This has been Star Talk, and I've been your host, Neil deGrasse Tyson, your personal astrophysicist. Thanks to Michio Kaku, Chuck Nice. As always, I bid you to keep looking at